Good morning. Welcome to sunny, warm Boston. Boston is one of the great centers of education in the world. It's also the seat of the American Revolution. And I think in these dark times, it's worth a reminder that the values of the American Revolution are based on the Enlightenment, rationality, and yes, education. Data presents a new opportunity to revitalize education. So I'm going to begin with just a few observations about innovation, then describe a little bit about the work that we're doing using learning science, applying learning science in education at McGrawHill, and then conclude with the work that how we're utilizing Spark and Databricks. So let me just sort of begin with this observation that the value really is not data. We need data, but it's really how we incorporate data and ship products and the speed of innovation. And that's ultimately the differentiator. I call that the spark factor. So the spark factor really is two parts. Part one, it's the technology. Spark, I think it's a no-brainer. But the second element is really the time to market. If you're not able to bring innovations to market in a timely, quick, and effective way, then all the data and the technology is useless. And time to market is really a function, I think, of two things. One, the people that you have, and second, the process. And this is where Databricks for us comes into play. So for us, Databricks underpins our innovation pipeline, and the way we think about innovation is really a very simple three-stage process. Managing a portfolio of research initiatives. Second, a subset of those go into product validation. And third, a subset of those go into product development. And it's really how quickly we're able to iterate around this cycle and bring new innovations to the market that we believe is going to differentiate us from our competitors. And we need a data science platform infrastructure to support this innovation pipeline. So let me talk briefly now about learning science at McGraw-Hill. So we're an old company. We've been around for over 128 years, primarily known until very recently as print publishers, textbooks. Now we're a learning science company. So we're in the midst of this massive digital transformation, smart digital, smart data, and lack of speed kills. So we have to innovate and innovate very, very quickly, major business transformation. So we have approximately 5,000 employees worldwide, K through 12, higher ed, and professional businesses. So yes, print will still be around. It's not going to go away. But as a software company now, we serve millions and millions of users worldwide. We have billions of interactions, digital data interactions. We have adaptive platforms which personalize learning, individualized pathways, and so on. I talked about three stages of innovation. Stage one is research in learning science and data science. And if we kind of zoom into that, step one for us is the research is around how do people learn and how can they learn better? And so one of the exciting things in learning is it's an interdisciplinary field of learning science, cognitive science, brain science, data science, educational psychology. And what we try to do is take the known knowns in learning science, apply them, build models and algorithms, create products Now, what's really important, even during the research stage, is having the ability to prototype and turn those prototypes around iteratively with our business and our customers. So research can't happen just kind of behind the wall, but we have to interact even during the research phase and have the ability and the infrastructure to interact with our customers and build rapid prototyping. And then finally, once the product ships, the models and algorithms are not fixed, right? They're first approximations. So we have to be able to collect data on a continuous and rapid basis to tune our models and update our models and algorithms. So as an example, recently we shipped, and in fact it hit the Apple stores, the iTunes store last week, a mobile product called StudyWise. So what we did was, in terms of acquiring knowledge and being able to recall knowledge in an optimal way, there are a certain set of principles in learning science. There are effortful recall, space practice, interleaving. These are known knowns of how to optimize acquisition of knowledge and recall. Then we took those known knowns, created a set of models and algorithms to optimize acquisition and recall, and created a mobile product that hit the Apple Store last week. The full cycle was about 8 months, from initial research to building the models and algorithms to product deployment. Data has started to come into our research environment. Right? So we use Amazon AWS. So stream data, JSON data is coming into our Databricks environment. And just a few lines of code, we've already started to do the analysis. Usage, which products in that space, what's the usage, what type of interactions are taking place, right? So, and this is very, very simple, 5, 10 lines of code. And we're able to analyze that data as it's coming in. Okay, Spark and Databricks. Want to give you another use case. This is a very common use case in higher education, K through 12. Students drop out, fail a course. Instructors have a hard time identifying which students are at risk. Can we identify students at risk preemptively before they drop out or fail? We have 2 superstar data scientists. So they built a classifier to predict abandonment. As a machine learning exercise, it's pretty straightforward. A lot of the subtleties are domain specific, but because these models have to serve and scale for millions of users, we're doing this in Spark. Right? So this is a standard logistic regression, training data, test data. We built a parallel pipeline for creating the classifier, Spark transformation, looked at the advantages of speed up using Spark and parallel processing. Now, all of this work is taking place in our Databricks environment. We don't have a single data scientist, it's a team. They need to collaborate on the models, annotate the models. We use the Databricks workbook. Evaluate model accuracy. Another aspect of this model is it's not just we need to be able to predict who's going to succeed and who will fail, but you want to be able to have a window before the event occurs so that you have time for intervention. So all of this is taking place, and now within the research environment, we are piloting this with a handful of customers. So this is still the research team. This hasn't gone to product validation yet, or it's kind of midway in product validation, and it's a great candidate for product development. So let me conclude now with this thought. So it's really, technology is important. Spark is at the center of our ecosystem. But if that's all we had, and if we didn't have an environment and an infrastructure to support our data science, we would not be in the mode of sort of agile being able to cycle out products on a very, very quick basis. So thank you very much for your time.